Hello everyone. In this lesson, we will solve this word problem. And in order to solve this word problem, we need to apply a formulas of the derivative of inverse trigonometric functions. Alright, so let's take a look at what they ask us to find. As shown in this figure, there's a camera mounted at this point O, and it's tracking a free-falling object. A free-falling object means that I discard all the air friction in this case. And the object is being dropped from the height of 1500 feet. And the question asks us to do this. Okay, it asks us at what rate does the angle of inclination theta, right here at the camera, the answer must be in degree per second. How does this angle change when the time is 7 seconds and at which the height of the object is given to us in terms of this equation, h equal to 1500 minus 18 t squared. Alright, so to work with this particular question, you need to find the equations. How to solve for the angle right here in terms of the height and in terms of t, because they are asking for the rate at which the angle of inclination theta changes when the time is at 7 seconds. Excuse me. So in order for you to work with this, what you do is you are going to draw a right triangle, right? Consider that this object dropped right on this ground, and at this point it will be directly perpendicular to the ground. So that's how we visualize that. Then, according to the movement of this object and the position of this camera, I draw a right triangle like this. Okay, so consider this distance is h, and from where the camera is mounted to where the object is dropped or touches the ground, I measure it to be 120 feet. Alright, so for us to work with this, they are asking for the change in the angle theta. So you need to find out what is theta equal to, right? So your angle theta, in order for you to find the angle theta, given h and given the 120 feet, you are going to use tangent to the minus 1 of the opposite over the adjacent. So opposite to angle theta is h. Okay, adjacent to the angle theta is given to you as 120. So to find the angle theta, we are going to use tangent to the exponent of minus 1. So tangent to the exponent minus 1 is the symbol to figure out your angle theta, okay, given the opposite and the adjacent. And then they ask us at what rate does the angle of inclination theta change. So in order for you to find the change in this angle theta, then you have to differentiate this equation. So you are going to find the derivative of angle theta as a function of time. So as a function of time, we'll answer this question here, the rate at which the angle of inclination changes. Alright? Okay, so I would like you to visualize this camera looking at this object and then moving according to this object. So it's more like a motion detector camera. The camera will move along with the object being moved. Alright, so let me complete this formulas on this equation. So if I differentiate theta in terms of time, I need to do the exact same thing on the other side of the equation, right? So I will have to take derivative of tangent to the minus 1 of the h divided by 120 as a function of time as well. So in order for me to complete this, I need to multiply by derivative of h as a function of time. So I also have to multiply by dH divided by dt. Alright, so I would like everyone to take a look at the hint that I have given to everyone above. You can differentiate this implicitly, like we learned how to differentiate an equation implicitly. So taking derivative of this angle theta as a function of time, it means that you have to take derivative of this function also in terms of time. But because you differentiate h in terms of time, you have to multiply by dh over dt. As we learned in previous lesson, how to differentiate an equation or a relation or a function implicitly. So now, if you cannot visualize that, then I would like to draw your attention to this formula that I've given to everyone. This is actually in a form of a chain rule. So in this case, what you have is you have derivative of theta as a function of t. So what you can do in this case is you can rewrite the differentiate the theta in terms of h, okay? And then you multiply that with the derivative of h as a function of time. So as you see right here, you can cancel this 2 out. And then your equation is exactly the same on the other side. So this is one form of the chain rule. And you can apply this formula to this particular word problem, or you can differentiate implicitly as I have shown for everyone right here. Okay, so I found this one is a lot easier. Working with this equation, differentiate this implicitly. Make sure that you differentiate everything in terms of time, and because you have the argument as h, you also have to time it by derivative of h as a function of t as well. Alright, so you can use this, or you can also work with this. So let's continue with this question by working with what I have shown everyone according to these formulas. So to simplify the process, you take derivative of this equation. Alright, okay, so you take derivative of this equation in terms of time. So derivative is an operation, so whatever you do on this side of the equation, you do the exact same thing on the other side. So now you see that you can solve for derivative of angle theta as a function of time with respect to t. So that means you are finding the change of this angle theta according to how far this object is being dropped on the ground using these formulas. So there's quite a few unknown here. Okay, so before I try to find dH over dt, I would like everyone to see that you can easily differentiate tangent to the exponent minus 1 of h over 120 using the formulas that we have learned earlier. So the formula that we are going to use in this example is formula number 9. So to find derivative of the inverse tangent of function u, you are going to have 1 divided by 1 plus u squared multiplied by du over dx, right? Okay. So what is your u in this case? Your u in this case is h over 120. So what I'm going to write is I will write d theta over dt. Okay, differentiate this part of the equation here. I will have it equal to 1 over 1 plus u squared. So u will be h squared divided by 120 squared. Okay, so I square both the numerator and the denominator in this case, and I multiply by du, okay, right, du over dx. So u is h over 120. So u is h over 120. Therefore, du over dx will be equal to 1 over 120. So I multiply by 1 over 120. So let's put it in this. And I also have to multiply by dh over dt. Okay, so how do I find dh over dt? To find dh over dt, the equation is given to us. So this is the equation right here. Okay, so given h equal to, so I will write it in here in a second. So dh over dt, I have to multiply by that as well, right? Given h equal to 1500, excuse me, so 1500 minus 18t squared, so I can easily find dh over dt, okay, by taking derivative of this function in terms of t, taking derivative of h with respect to t. So derivative of 1500 will be equal to 0. Derivative of 18t squared will give me negative 36t. Okay, so in the end, I am going to take this and substitute it right in there. So let me rewrite that for everyone. So d theta over dt, the change in this angle according to time, will be equal to 1 over 1 plus h squared. Okay, as now I'm going to square the 120. 120 squared will give me 14,400. Time this by 1 over 120. Okay, so I can put this in the bracket to clarify it. So negative 36t. So this is your dh over dt. Okay, so now you can see that you can simplify this equation first, simplify it first, and then you can substitute in the value for h and the value for t, and we are going to find those two values in a minute. All right, okay, so I will have it as d theta over dt. I am going to simplify this denominator. So 1 over 14,400 plus h squared, the whole thing divided by the denominator. The reason I am doing this is because I want to simplify this, divide this into 1. Okay, I divide all of that into 1. Times 1 over 120. And then I also have to multiply by negative 36t. So as you see, this whole thing, 1 divided by this entire denominator. So what I would do is I will write it as 14,400 divided by 14,400 plus 8 squared, okay, times 1 over 120, multiplied by negative 36t. Alright, okay. So you need to substitute in the value for h, and you need to substitute in the value for t. So what I'm going to ask you is to take a look at the word problem one more time. So at the time t equal to 7, okay, you need to figure out the height at that t equal to 7 seconds. So it's very simple by taking 7, substitute into these formulas. Okay, so at the time t equal to 7, the h will be equal to certain values. So at t equal to 7 seconds, h is equal to 1500 minus 18 times 7 squared. So I should have it as 1500 subtract 18 times 49 And then I'm going to give everyone the value right here, which is 618 feet. Okay, so what you do is you are going to substitute this into here, and you also substitute this as t equal to 7 seconds, because of that is the corresponding value. Okay, so t and h, t equal to 7, okay, at t equal to 7 seconds, h will be equal to 618 feet. So let's substitute that in to see what we get. All right. Okay. So, all right. So can I just go back, and I would like to show everyone that I want to simplify this as well. So that and that cancel should give me 120 right there. Okay. So then I will have d theta over dt will be equal to, now I turn this into 120 times negative 36t, the whole thing divided by 14,400 plus 8 squared. So I simplify this equation to write it as this. Okay, so just to remind everyone. So now I'm going to substitute in the value. Okay, I will evaluate at T7H equal to 618. So it's 120 multiplied by negative 36 multiplied by 7 and divided by 14,400 plus 618 square. So doing all of this calculation, I should have this value. So in this case, the answer will be negative 0.07630 radian per second. Okay, so don't forget it's radian per second. Then what I need to do now is to convert this into degree per second, according to the question that's asked me to work with. So 0.763 radian. To convert from radian to degree, I need to multiply by 180 divided by pi radian. Okay, so you see now this radian cancel out. I will have a degree per second in a minute. So take this number, okay, multiply by 180 divided by pi. Then I round to 3 significant digits. I should have the answer as negative 4.37 degree per second. All right. Okay. So let me recap what we need to figure out. So according to this word problem, what they ask us is, so as the object drop, the height will decrease until you hit the ground. Okay, so hit the ground, that means the h will become 0. So when at the time when the object is being dropped, this camera is going to move along with the how this object is actually decrease in its height. Okay, so the angle where you mount the camera will also change according to the time. So in order for me to figure out the equation, to figure out the angle theta, how it change, I have to start out with theta equal to tangent to the negative 1 of h divided by 120. It means that the opposite over the adjacent. Okay, so I should write this for everyone to remember here. So here's my angle theta, right? So tangent of theta will be equal to h divided by 120. So in order for me to find h, I have to use the formula tangent to the exponent -1. Okay, this operation right here of h divided by 120. And what I'm going to do next is I will differentiate this equation implicitly. So that means I will differentiate it in terms of time. So if I differentiate theta in terms of time, I answer this question right here. At what rate does the angle of inclination theta change it? So for this one to change, d theta over dt representing what I have to find. So differentiating this angle theta in terms of time, I do the exact same thing on the other side of the equation. However, I have to apply the chain rule in this case. Okay, so to find the derivative of this h as a function of time, I also have to multiply that by derivative of h as a function of time as well. Okay, so to find this derivative, I need to apply the formulas where the tangent derivative of tangent to the -1 of u f as function of x, as we learned earlier, will be equal to 1 over 1 plus u squared times it with derivative of u as a function of x. Okay, so we learned these formulas in previous lesson. Okay, and I summarized it here for everyone. So just to go back and show everyone that formula is which is right here. Okay, so when I work with that, I work with h, okay, in terms of time, the height in terms of times. Therefore, u now become h over 120. So du over dx will be 1 over 120. Substitute into the formulas 1 plus u squared in this case, time du over dx. I also have to time dh over dt. And how do I get dh over dt? Is to differentiate the equation that given to me. Differentiate this equation given to me, I have -36t. So I substitute them all into these formulas. I simplify that. I simplify the denominators. Okay, 1 divided by a fraction, I have to inverse and multiply. So therefore, I take common denominator so I can inverse the fraction. At the same time, I can take this, cancel with this 120. So to have 120 here. All right. So at the time t equal to 7, I have to figure out what h is. So at the time t equal to 7 here, h will be decreased. Alright, so instead of 1500 at the time t equal to 0, right here at the time t equal to 0, it will be 1500. When the time increase, my h will decrease. Alright, so when decrease at the 7, I figure out that h is equal to 618 feet. Okay, after I got that two value, the two corresponding value, I substitute into this equation derivative of the angle theta with respect to t to represent the change in this inclination angle according to time. And when I figured it out, I got the angle as negative because of the object actually falling, and the angle has to be a negative value to representing the correct direction that we are using in this case. And after I figure that out in radian per second, I have to convert that to degree. And to convert to degree, you are multiplied by 180 degree divided by pi radian. And in the end, my angle will be -4.37 degrees per second. So in this case, that your angle of inclination will decrease at the rate of 4.37 degrees per second. All right. Okay. So the negative here representing that your camera is moving according to the object being dropped. So the height is decreased. So therefore your angle also have to be decreased. All right. Thank you.